wanted to kind of add a little bit of a modeling aspect to it, try to get out of the way a little bit. Here I have two methanol molecules. So we have kind of our simplest alcohol with a methane group, but replacing one hydrogen with a little hydroxyl group. You can see the way then that shape gets created. And it's a little tetrahedral with a little bent structure here on top. And when I have two of them, the interaction between them is going to be hydrogen bonding. And as you saw, it's not oxygen to oxygen or hydrogen to hydrogen, but it's actually going to be the hydrogen to oxygen. That's why it's called hydrogen bonding. Hydrogen to the partial negative over here, due to the difference in electronegativity here and the negative dipole, partial negative and partial positive. And that means we're going to have a high degree of intermolecular attraction between these. And that's why we see alcohols having greater boiling points than similar alkanes, alkenes, and alkynes, those of the same size. And that's because it takes more energy to get them to separate because they're more attracted to each other. This also explains the high degree of solubility that we see, because water, being very polar, and especially polar substance, because of these two, the oxygen pulling the electrons and the lone pairs appear, and that means that water can interact. Water can hydrogen bond. That's my representation of hydrogen bonding. Can hydrogen bond with that hydroxyl group as well, and therefore this molecule can really get spread out in the solution, and it's highly soluble. And so smaller alcohols have high solubility. So I hope that helped, and I'll see you soon, and we'll do more practice on this.